All right, we are recording now, and I will share my window. Do you want to see my entire screen? All right. So I have been successful in building a model. What this model does is make prediction based on the severity levels of osteoarthritis off of the pictures it's been trained on and what it has come to learn and observe and take away from the differences in the pictures. So the whole project uses a deep learning model to predict the severity of knee osteoarthritis from X-ray images using a simple web interface built with Gradio. So I built the model with Google Colab, and I used, still on Google Colab, I'm using Gradio interface to deploy it. So you can get a URL if you were at home or if you were on your phone and you had access to your X-ray file and you have access to a picture or the media file. You don't have to wait until the doctor gives you a diagnosis, and the challenges that comes with that. This is what we're trying to solve. It's more like applying deep learning into the healthcare to try and streamline certain services. So let's get right down into it. Google Drive, I told you earlier, the model is saved in my Google Drive, so we have to find a way to bring it right down into the scripts because every runtime is different. Now we install the dependencies. First respect is given to Gradio, so PIB install quietly for the -q Gradio. If not, it will list a bunch of things that are not particularly necessary at this point. Then we import. We import Gradio as GR, import TensorFlow as TF, we import NumPy as MP, import Pillow, import image. These are what we need to process this. Now, I will show you how the system works and how the users can interact with it through a simple web interface by the time it generates the URL, okay? So why we see defining of focal loss here is because when it's a medical data set, first of all, we're dealing with, so it doesn't have the privilege in the sense of size and wealth of data set due to the typical constraints involved in getting medical data. There's a lot of regulations, a lot of permissions. It's not just data you can scrap. You need people's permission to use their data when it comes to medical because they probably came to you and you're gonna have to let them know and they need to sign off on it. So yeah, typically the way the world goes, there is gonna be skewness. Nothing is ever straight, right? Even when we deal, nothing is ever linear. Although we do learn it in linearity, but it's never linear. So my data set was hugely skewed, and my class weighting technique as an attempt to balance the data set was not having much of an effect. So I opted to use both the class weighting, which is a function, a built-in function, and the custom function for this focal loss, which is why you're seeing it defined. All right, because if I don't define it, this script will throw off errors. I have to define it and put in its parameters. So now we get back to installing my model from Google Drive. Again, PIP install quietly, Google G down. Then after installation, we import it. That's my Google Drive link for that particular file. Then we download the model file from the correct Google Drive link because I was having a little bit of issue with finding the correct one. I created many models, and I left this one, the name, in the generic model.keras for clarity because I have renamed a lot of the other ones I created. So we download the model, we load the model, and again, when we are loading the model, we have to still pay attention to that custom object, which is the focal loss, right? Then we compile the Adam optimizers, the learning rate. These are hyperparameters that you can tweak and see. If you were to be in the training phase, these are some of the hyperparameters you could be able to tweak to see if you will get different outcomes and accuracy and performances. Mine is not the ultimate performance by any means. So KL grade mapping, this is simply Kelvin-Lorentz mapping. 0 for normal, no osteoarthritis, 1 for doubtful, questionable osteoarthritis, not really sure what's going on there. Then 2 for mild, definite osteoarthritis, you have a problem, but there's still a possibility that joint space are not narrowing yet, or they are. But everything is a suspect at the mild, at the number 2. So at number 3, definite joint space narrowing, it gets serious. Moderate osteophytes, we have confirmed you will be needing attention. Then when it gets to severe, this is really, really where the patient will be in discomfort, as with time they will start experiencing a bone-on-bone contact with their, it's like machines without galvanization, or without oiling. It's an absolutely undesirable scenario, and it causes stiffness, it causes swelling, it causes general discomfort. It totally affects your quality of life and your mobility. Hence, trying to get diagnosis as quick as possible by using automated method like this, a perfect version of this will be deployed to just, reduce the waiting times on expert interpretations, which are still done by humans who might be having a bad day. Not to say that the experts are not. They do their best, but humans have limitations. Robot, you just need power and the right settings and the environment they need. They don't have to go on shifts. They don't have to swap. So because when you want to communicate with computers, especially image-wise, you have to be very consistent in your size, your format, and whenever you want to manipulate the images, I'm pointing at pre-processing in grayscale now, okay? So that was that. Then prediction function, and this prediction function is basically the whole point of this model, of this script particularly, so to help the model make predictions based off of what input you've given it. Then we return it, then the script will return you a feedback. The graduate interface is there on iFace equal to GL the interface. So in the text box, you're going to see on the right the KL grade, the diagnosis, and the confidence. So the title of the project is Osteoarthritis Detection and Severity Analysis. So you also see a description and a guidance to upload a knee X-ray image to analyze osteoarthritis. But I have two options. I can either do it here or take it to a new tab. But for cleanliness, let's go to a new tab. So in this new tab, you should already have your file that you want to analyze, okay? So you're gonna submit it on this tab, but first you have to paste it here, all right? So I click on this, and sorry, I was working on it, so it will jump right at you. So this is an auto test folder. This folder was not used in the training or the validation of my model, right? They were just left for the testing phase, not all of them. So it's basically filled with pictures that the model has not seen. So we could choose it from anyone's severity, but I like the middle guy. So we choose one of the pictures in the mid. So yeah, you can have a preview of the picture you're looking at. Then we submit. When we submit, we allow for a little time for the analysis to be done. It will give us a verdict. All right, it is predicting that the image it's looking at is of mild, definite osteophytes, possible joint spacing. So this is why I say everything is a suspect. All right. So The scale grade 2 is mild. Confidence level is not that high. We could work on that, but it's functional. What I've been able to do is to create a model, deploy it. Improvements can be made on the model, different versions of it. I'm using an efficient net B0 transfer learning. One could train their own CNN convolutional network from scratch if you have the resources and the time. One could also leverage other optimal transfer learning. I just use this. There are many ways of achieving this. Even the deployment could be done with Flask. There are many ways of achieving this, but I have just done this, and this is the end of my work. Thank you very much. Have a good day.